Hi, this is Mr. Mack. We're talking today about rate of change. Now, the concept here is we start out with some kind of a function that relates to quantities. Let's imagine that we have a function that relates time with distance. And let's let the time be given in hours and the distance be given in kilometers. And let's say we're going to travel along an interstate roadway, and we're going to say that the distance we've traveled is directly related to the amount of time we've been traveling. Let's imagine after we've been traveling 2 hours, we have traveled 100 miles. And after we've traveled After we traveled 5 hours, we've traveled 250 miles. Or kilometers. I'm sorry, these are kilometers here. Now, if we want to talk about rate of change, what we really want to know is how much has the distance changed, maybe from the 2-hour to the 5-hour mark, and how much has the time changed? Well, now notice the change in distance is the value of the distance at this point minus the value of the distance at this point. And that actually is this vertical line length right there. So the change in distance would be the second distance minus the first distance. And the change in time would be the change in second time, or it would be the second time minus the first time. That would be this horizontal distance right here. Now, ordinarily we'll use a small triangle. That's really the small Greek letter delta to represent change in. And so this would be the delta distance would be this vertical part of the triangle here, and delta t, change in time, would be this horizontal part here, and the change in time would be the second time minus the first time. Well, the rate of change then would be what we get when we divide the change in distance by the change in time. So d2 minus d1, oh, did I do that? I did that. That should be a 1 here, guys. The second distance minus the first distance. d2 minus d1 over t2 minus t1. Now, in this particular case, if you look at it, the change in distance is how many kilometers have changed, and the change in time is how many hours have changed. So if you look at the units, it is kilometers per hour, which is a fairly important concept to understand. Now, one thing that's also true is if this is a straight line relationship, then the rate of change isn't changing. And you could bear that out by what you know in geometry. This delta d right here divided by this delta t would be the ratio of two sides of this smaller right triangle. And this delta d right here divided by this delta t right here would be a ratio of the corresponding sides in that larger triangle. And as you can see, since the triangles are similar, those two ratios would be the same. So the rate of change for a linear function is constant. Now, when we have a linear function that has a rate of change that's constant, we call that rate of change the slope. Usually we refer to it by the small letter m, and the formula for that would be y2 minus y1 over x2 minus x1. Now, it doesn't really matter which point you let be point 2 and which point you let be point 1. Let's imagine that we decide to let this point right here be point 1 and this point be point 2. Now, point 1 was 2, 100, and point 2 was 5, 250. So the rate of change of this function would be y2 minus y1 over x2 minus x1. Now, 250 minus 100 is 150, and 5 minus 2 is 3, which reduces to 50 kilometers per hour. Now, think about it. If when you have traveled for 2 hours, you've gone 100 kilometers, and when you've traveled 5 hours, you've gone 250 kilometers, how fast are you going? Well, you're going 50 kilometers per hour, and that's the slope of this relationship. It wouldn't have mattered, though, if we had let point 2 be point 1 and point 1 be point 2, because we would have gotten 100 minus 250 for the top, and we would have gotten 2 minus 5 for the bottom, and that's negative 150 over negative 3, which gives us exactly the same 50. So it doesn't matter which point you pick to be point 2 and which point you pick to be point 1. Now, in this particular section, you're going to be asked to find the rate of change, or the slope, given 2 points, and you would use the slope formula. Let's just go ahead and write this up here. The slope formula is m is equal to y2 minus y, what happened here? y2 minus y1 over x2 minus x1, and you just put in the appropriate values in those spots and work it out. If you're given a graph with a line and asked to find the slope, what you need to do is you need to find places on the line that cross right at what we're going to call grid points, or as close as possible to grid points, and let one of those points be point 1 and the other be point 2, and then work out the slope using the formula just as you've done here. And we're done.